Hello everyone, welcome to part 22 of my video series on probability distributions. So today we are going to talk about the relationship between different probability distributions. So far in this video series we have covered around 17 probability distributions. So in this video we are going to see how exactly they relate to each other. Understand that before coming to this video, I suggest you to go through those 17 probability distributions which are in different parts of the video series and then come back here, because in that way you are going to get the most amount of benefit from this video. So let's dive in. So first of all, let's start with Poisson versus exponential. So what is Poisson distribution? So in the Poisson distribution, we try to see the probability of k events per unit time, given that we know the average number of events per unit time. Just to give an example, what is the probability of me getting 10 new subscribers per day on my YouTube channel, given that I get 5 new subscribers per day, every day basically. So what is the probability of that? So this is Poisson distribution. But exponential distribution asks you the inverse question, the question that is opposite. So here we are talking about k events per unit time. But in exponential, they're asking us what is the probability of t unit of time passed for one single event. The given thing is the exact same. There is no difference in the given thing. So just to give an example, the probability of 0.2 day passing for one new subscriber. Okay, so basically here we're asking how much time is being passed for one new event. That is the exponential distribution. Just to summarize, we are asking different questions in the two cases. So for Poisson, we are asking event long per time, and for exponential, we are asking the time per single event. Next, let's talk about Bernoulli, binomial, and Poisson. So Bernoulli is very simple. It is nothing but probability of success or failure of a single trial. And for example, you can say, what is the probability of a viewer subscribing, right? So we can call subscription as a success event. But in binomial, we are saying, what is the probability of getting m successes in n trials? So just to give an example, what is the probability of 5 viewers subscribing among 8 viewers? So you can think of this as n Bernoulli events taking place. So for example, here you can see we have 8 events happening, we have 8 trials happening, and from that we are getting 5 successes. So that means there are 8 Bernoulli trials happening in this particular example. So what is the relationship of Poisson? Now, the relationship of Poisson with binomial isn't that easy to just see, but I will give an example here, then I think it will be clearer. So for example, if you say the probability of 10 new subscription per day on my YouTube channel, given that I get 5 new subscription per day, this is the example of Poisson distribution. But how is it similar to binomial distribution? You can see that in this particular example, the probability of subscription, that is probability of success, is not known. In binomial, the probability of success is known, but for Poisson, we don't know the probability of success or subscription in this case. And we also did not restrict the number of viewers. We are saying the number of successes, right? We are saying 10 new subscription or 10 successful event, but we are not saying how many trials we are actually doing. In binomial, we are restricting the number of trials. We are restricting the viewers to 8 or some number. But in Poisson, we are not restricting the total number of viewers. The number of viewers can be anything. It can be infinity. Since the number of viewers can be infinity, the probability of success or the probability of subscribing will be approximately 0 because of this number being able to be infinity. That means when these conditions hold, that means when we don't know the probability of success, the number of events or trials can be infinity, and the probability of success is close to 0, then binomial converts to Poisson. So next, let's talk about Bernoulli versus binomial versus categorical versus multinomial, the 4 distributions. So Bernoulli, very simple, probability of dislike a video by one viewer. So one single trial happening and probability of success or failure. So this is basically what we are doing here. We have one trial, one viewer, and we have 2 possible outcomes, like, dislike. In binomial, we have probability of dislike a video by 10 viewers. So what does this mean? This means that your number of trials here is actually more than 1. So it's 10 Bernoulli trials in this case, and the possible outcomes are 2. In that case, we can model this using binomial. In case of categorical, you can see we can ask questions like this: probability of dislike, or neutral a video by one viewer. So understand that there are one viewer, that means only one Bernoulli trial, only one trial here, and the possible outcome can be more than 2. Now here we have 3 possible outcomes, but it can be 5, 10, or anything. So multinomial distribution, I think you can all guess now, there will be more than 2 possible outcomes and more than 1 trial. So So that is exactly what is happening in multinomial distribution. So these are the four things which are highly related to each other, and they differ by the number of trials and the number of possible outcomes. Next, let's talk about Bernoulli versus beta versus categorical versus Dirichlet. So Bernoulli, very simple, probability of like, dislike a video by one viewer. Beta distribution is a little bit critical, but I think you understand this now. We are going to get the probability of P like, that is probability of success, given the samples we have seen so far. That means here, the random variable itself is probability of liking, probability of success. For example, in this distribution, we may want to know, what is the probability of P like equal to 0.2? Or maybe what is the probability of P like is equal to 0.87, etc. So that is the beta distribution. Next, let's talk about categorical distribution. We have talked about this in the previous slide, but still, this is what it means. Probability of like, dislike, or neutral a video by a single viewer. So Dirichlet distribution is very similar to beta distribution, but it is just for the categorical case. So probability of P like, P dislike, and P neutral. That is what Dirichlet distribution is, given the samples we have seen so far. So understand that here we have more than two possible outcomes. In that case, we are going to use Dirichlet distribution. And here, in this case, there will be three random variables for this distribution: P like, P dislike, and P neutral. Now understand that, for example, if there were 5 possible outcomes, then there would be 5 random variables, and we would get the probability of those 5 random variables. Let's talk about binomial versus geometric versus negative binomial. Let's assume that a viewer subscribing is a success event, and the probability of that is P. In binomial, we are just asking what is the probability of getting 4 subscribers from 20 viewers. It can be a different number of viewers and it can be different number of subscribers, but just for this example, we are using 4 and 20. So there can be different cases. For example, in case 1, your viewer number 2, viewer number 5, 8, and 11 have subscribed. The other 16 did not subscribe. In case number 2, these 4 subscribers can be viewer number 1, 6, 8, and 12, etc. There can be many other cases. In geometric distribution, we ask a different question. We ask what is the probability of getting the first subscription at the 20th view. That means the first 19 viewers cannot subscribe. The 20th viewer has to subscribe. That means probability of failing until the first success. So we are only concerned with the first success happening at a certain number of events. So negative binomial is actually the generalized version of geometric. So what does that mean? So here we are asking probability of getting the 4th subscription at the 20th view. Now you may confuse this with binomial because these things look similar, but here is the thing. In negative binomial, this can be one of the cases. Viewer 2, 5, 8, and 20 have subscribed and the others did not subscribe. Case 2 can be viewer 3, 9, 17, and 20 have subscribed and others have not subscribed. You can see a pattern here. The pattern here is that the 4th subscription has to occur in the 20th trial. That is the fundamental difference between negative binomial and binomial, because here you can see that the 4 successes can happen at any time. But here the 4th success has to happen at the 20th view. So that's the difference between these 3 distributions. Let's now talk about binomial versus hypergeometric. They also are very similar, but there is one fundamental difference and it is very easy to confuse them. So let's assume that we have 10 red balls and 5 green balls. In binomial distribution, what we are asking is, if you randomly pick 3 balls, from these, what is the probability of getting 2 red and 1 green ball? You can assume that picking a red ball is a success and picking a green ball is a failure. Here, there is an assumption. The assumption is after you pick each ball, for example, suppose the first ball you pick is actually red. Then there should be 9 red balls and 5 green balls. But no, in binomial, they are saying that whenever you pick the red ball is automatically replaced. And so no matter how many balls you pick, the number of red balls and number of green balls will remain the same. So it is sampling with replacement. So there is no change in probability of success whatsoever when you pick up a ball. But in hypergeometric, this assumption is relaxed. You are asking the same question, what is the probability of getting 2 red and 1 green? But your assumption is different. What is that assumption? That assumption is after you pick each ball, it is not replaced by a new ball. That means when you pick 1 red ball, there is now 9 red balls and 5 green balls. And so the probability of having a red ball has changed, right? It has reduced. That means probability of success changes after every pick. That is the difference between binomial and hypergeometric. Let's now talk about normal versus T versus chi-square versus F distribution. Normal distribution, it is very familiar to us. It is nothing but the bell-shaped curve with thin tails at both ends and with a central tendency. So in normal distribution, the sample size should be ideally greater than 30. So in T distribution, it is very similar to normal distribution, but it is adapted for cases with low sample size. That means when sample size is less than 30, you model that using T distribution. So the tails are also fatter, and the lower your sample size, the fatter will be the tails of the T distribution. Chi-square distribution is actually a generalized version. Chi-square distribution is actually inherited from the normal distribution, so it is nothing but the sum of one or more squared standard normal distribution. That means distribution is square 1 plus distribution is square 2 plus distribution is square 3 and so on and so forth. So standard normal distribution, it has mean 0 and standard deviation of 1. So when we say a chi-square distribution with 5 degrees of freedom, that means it is nothing but a sum of 5 squared standard normal distributions. Okay, finally F distribution. F distribution is nothing but the ratio of two chi-square distributions, and those two chi-square distributions can have different degrees of freedom. For example, we talked about 5 degrees of freedom right here. Next, let's go to exponential versus Erlang versus gamma. Exponential, we know what that is. Probability of t unit of time passed for one event. So how much time is passing for one single event? That is exponential. For example, this is an example I gave before. In Erlang, this is actually a generalized version of exponential. We are now saying probability of t unit of time passed not for one event, but for r number of events, right? And obviously, r will be an integer. It can be 0, 1, 2, 3, etc. For example, here we can say probability of 2.5 days passing for 10 new subscribers. In gamma distribution, it is an even more generalized version. So it is saying that here r should be positive integer, but in gamma, your r can be any positive value. It can be any positive real number. So it can be 0.5, 10.556, etc. There is no assumption of r being integer, right? So it can be some floating point number as well. So finally, let's talk about exponential versus Weibull. So Weibull is basically a continuous distribution with 3 predefined parameters. You know that if you followed my series so far. So these are those parameters: shape, scale, and location. So when your location is 0 and your shape parameter is 1, then Weibull transforms into exponential distribution. So what is the significance of this? So there is a thing called hazard function in survival analysis. So hazard function is basically as follows: probability of survival beyond time t, given that survival occurred up until time t. This is the hazard function. So when you have the exponential distribution of k equal to 1, your hazard rate is constant. K less than 1, meaning you can model hazard rate which decreases over time. And when k greater than 1, you can model hazard rate that increases over time. So that is all about the relationship between these 17 probability distributions. I hope you enjoyed the video. If you like the video, please feel free to subscribe and share. And also, you can donate to our channel, so the link in the description. Thanks very much.